Hi everyone, it's Miss Abby and I'm back from Evelyn Metter Library, and today I'm going to show you a really cool feature in TinkerCAD. I know we've done a couple of classes in Arduinos before at the branch, so this is an opportunity to get to play with an Arduino emulator. So TinkerCAD lets you play with a virtual Arduino, which is really fun because you don't have to deal with all the tiny wires and light bulbs, and so this is getting started with your first Arduino program. So start out by going to tinkercad.com, and from there you will, if you are under 13, you are going to need to go and get your parents to put in their email address and they will have to validate your account. If you are over 13, you can use your own email address. If you have come in and done a TinkerCAD class in the branch, and you usually use a class code to log in, you can contact me and I can get you that information. Just go ahead, I think Facebook is probably the best way. Send a Facebook message with your name, and if you know when you came, that would be helpful too. So start with log in or sign up. I already have an account, so I'm going to go ahead and sign in with my email. So it brings you up first to your recent designs. This is just a quick dashboard of anything you've designed in 3D. Today we are not going to do that. Today we are going to start by going over here to Circuits. You click there. So here you can also see my recent circuits. Today we are going to create a new circuit. The first thing that I want you to do is click up at the top here to rename your project. So right up here, TinkerCAD gives it cute, funny names that they fill in themselves, but those names are just as useless as new project when you're trying to find which project this is. My suggestion for a name is Blink or Hello World, because this is the Hello World version for an Arduino. I'm going to call it Blink It, since I already have one that says Blink. Make sure to hit Enter to save your changes. After that, we are going to come over to the components, which are over here on your right-hand side, and it shows Basics. That's all we're going to need, but you are going to have to scroll down, and you're going to grab this breadboard, bring it over here, and you can name it if you want, but we're just going to use one. If you're doing a complicated program, name things. And we will grab an Arduino. Just click and drag that over and kind of line them up. You can use your scroll wheel to zoom out and just click and drag to move your view around. So just go ahead and line them up about like that. It doesn't need to be fancy. This is a breadboard. It's a device that allows you to build circuits without needing to solder them. Each tiny hole is surrounded inside with a conductive metal, and they're linked like this. Each short column of 5 are linked with a gap in the middle. Those are labeled down the side that's on the bottom of yours with numbers. You'll see those 1, 2, 3, 4, 5. There's a gap in the middle, and they are not linked across the gap. So you can see this in this illustration, how it shows the green lines where everything is linked. The long rows on the side are linked perpendicularly. So that plus and minus down at the bottom, those go all the way down, and you'll see again those lines at the bottom. The long rows on the top and bottom are labeled with a positive and a negative. So you can run your power through one and your ground through the other. There are letters along the side that show the rows, and so that helps us define where we're putting something. So if I say put it at A5, you'll go and you'll look at you'll find the letter A, and you'll go down 5 rows, and that's where you'll put it. And we're going to start putting our circuit together. So the first thing we're going to use in this circuit is an LED. So that's over here. It's right at the top, very common. So grab the LED and drag it over to the breadboard. So I'm going to put it right here for a second and show you. An LED has 2 legs. One is positive, one is negative. The bent leg indicates your positive leg. The bent leg is usually on the left if our diagram is correct. That keeps it consistent so everybody can find it. So we're going to grab our LED and we're going to place it on the breadboard. And the nice thing about a virtual breadboard is it goes exactly in the spot we want it. We don't have to worry if it connected in two that were on the same. So if also in TinkerCAD you can hover here and it will show you where your breadboard links are. So that's very handy. So go ahead and put it not in row A. Mine is, as you can see, it's in C13. And the other one is in, the positive leg is in C14. Just don't put it in row A because we're going to have to put something else in row A. So you don't have to place it exactly where I did, but it might help you later. So the next thing we're going to grab is a resistor. So you'll see that's right over here next to the LED. These are going to be the basics of most of our starter projects. And we are going to put it in the same column as the positive leg. So it has to go in the same column as this bent leg. We're going to put it in row A so that the top end of it reaches up here, terminal 2 reaches into A, and the bottom one reaches into this positive row down here. That's really important. If it is up 1 and this is in the negative row, it's not going to get power. So resistors are actually omnidirectional. It doesn't matter which way you place them in the thing. So now when we click on the resistor, this pops up and it's got 1 and the K stands for 1000, and then this little symbol is called an ohm. We're going to switch that to ohms and we're going to change our resistance to 220. When you're working, and you'll notice the color of it changed to the universal resistor color coding. So when we're working with real resistors, they have these little stripes that indicate how much current they resist. So basically, if we plug this LED directly into our Arduino, it'll blow out. And I can show you all that later because this circuit will show us if it's got too much power going into the LED, all without actually blowing out real LEDs. I love these things. So next we are going to grab wires. On TinkerCAD, wires, you can get them just by clicking a dot. Anywhere you click. Click 2 and ends and you have a wire. So I'm going to press the delete key on my keyboard to get rid of that. And also you can click over here, and anywhere you click it'll kind of pin that wire. So that lets you kind of draw around with the wires, but it helps you create your circuit diagrams looking nice. Once you've clicked it back, you can delete it again. So we're going to start by grounding our LED. So I'm going to go ahead and click right here in A13. So that's in the same column as my negative leg. And I'm going to click right there, and then I'm going to drag down and click into my negative bar down here. I'm going to change my color to black because this is a grounding wire. It's not required that you use black for grounding and red for power, but it makes our circuits look pretty and it really keeps things neater. So I like to do it that way. So our next wire is going to be our positive wire. So we're going to come over here and we're going to click in the D13. So you'll see it says 13 on the little Arduino, and when you hover it says D13. Click there and then anywhere in this positive rail. And I'm going to change this one to red to signify this is where the power is coming through. So we have one more wire to complete this circuit. We're going to come over here, click ground. It's right next to the D13, and then click on any of the dots here in this negative rail. Again, I'm going to change the color to black just because it's a grounding wire and that helps me keep track. If you look here at this picture, you'll see how the current flows up through the Arduino, through that pin 13, and it flows up through the resistor, through the positive leg of the LED, and then out the negative leg of the LED, and through our grounding wires back to our grounding port. Circuits always have to be a complete circle or they will not work. So anytime your circuit isn't working, look for your circle. Here is a circuit diagram. So if you look at this image, you'll see it's an Arduino pinout. and you'll see that D13 right up there. They've got the ground at the bottom because, again, this is a circuit diagram, not an actual image. So you'll see there's a wire going from D13. There's a little squiggle there, and it says that 220 ohms on the side. That stands for the resistor. And then that little triangle with the arrows, that signifies an LED. There are all sorts of standard symbols for all kinds of things, and you can definitely look up a chart for those. But then you'll see we go resistor, LED, back to ground, just like we did in our actual circuit. So now we're going to start coding this. We're going to come up here to this code editor, click it. It has blocks. Today we're going to use text. The Arduino software that's built into the computers does not have block coding, but it is fun to play with the blocks here in TinkerCAD, and you definitely have an opportunity to do that. So once you click text, this will erase the block code that you already have. So that's okay. So we're going to say continue. And it actually turned my blocks into text. I don't know if it always does that or if it only keeps that for the sample, but we're going to delete that. I'm going to put the code up on the screen here. And I know it's kind of long, and it's vitally important that everything is exactly as it looks here. Capitals, parentheses, all of the things. You only have to worry about typing the yellow words. Anything with a double backslash in front of it, or a double slash in front of it, are notes. So you'll see here, when you type in that void setup, open close parenthesis, and then open bracket, that initializes, that is the setup function. This initializes the program when you press power. Pin mode with that capital M, and then open parentheses, and this LED built-in output, that tells the Arduino to use pin 13. You can actually change that LED built-in to any pin number, and you'll have to do that if you want power to go through that pin. So if you used, instead of 13, if you used 12 or 10 or 11, any of those other numbers, you have to type those numbers instead of LED built-in. Make sure to get that comma, output, close parenthesis. There's a little semicolon hide in there before that close bracket. So now we're going to add a loop. So we've set up our program. We've got our pin mode initialized. We're going to go ahead and type void loop, open close parenthesis, open bracket, and then on the next line, you'll have this digital write, and then LED built-in, comma, high, close parenthesis, semicolon. So this turns on the LED, and high is the voltage level, so that turns it on at full power. So then we're going to delay 1000, which is 1 second. The Arduino counts in milliseconds. Delay 1000, which waits for a second. Digital write LED built-in low, which turns the LED off by making the voltage low. And then we'll delay for another second. So once you have typed all of that, and go ahead and pause this video if you need to. Remember, only type the yellow text. You do not need to type the white text. Once you've completed your typing, you should notice if you had typed everything correctly, every once in a while things will change color. This void turns purple, this delay, the seconds turned blue. That's a good sign. That means you typed it right. It should look exactly like this. You should have 7 lines of text, and it does number the lines for you because it will tell you if there's an error on one of those lines. Once your code is correct and matches this, go ahead and click Start Simulation. So you'll notice the LED is blinking and the onboard LED is blinking. Once we click Stop Simulation, we can click this wire and drag this endpoint over to 8. So then we have to come over here and we want to change this to 8. You have to change it everywhere. You just change one, it's not going to work. And see, my 8 turned to color too. So start simulation. And now only that LED is blinking and the onboard one is no longer blinking. D13 is linked up with this onboard LED here. So anytime you use that in a program, it's nice because we know for sure if this wasn't blinking, but this was blinking, we know that there's a problem somewhere in the way we've set up our circuit. So if I go stop my simulation, we have this like that. I'm just going to copy and paste it back into text there. And if I move this, let's say I accidentally put the power up here. Or no, let's leave the power. Say my resistor is in the wrong thing and it's not hitting my positive LED leg. When I hit start simulation, I can see my code worked because my onboard LED is clicking, but this LED is not lighting up, so that means there's something wrong with the physical circuit. So if I hit stop, I can fix that and move my resistor over so that it's lined up perfectly with my LED. Start it, and now it's working again. So this is the blank circuit. This is really the first project you want to do within Arduino. A fun thing you can do is experiment. We can put some more LEDs out here. You can change the color of your LED here. Make it orange, green. Change the color of your LED. And you can either make them work together in one circuit. So by doing that, I would just leave my power here. And I've got this resistor in here, so I can just make my circuit. If I click like this, start simulation, they're going to do the exact same thing together at the same time because they're both powered into this 13 because it's what's running power all the way through here. If you want to stop that, I'm going to scoot my LED up a little. We're going to leave the ground alone, but I can move the resistor up. Actually going to move the LED up to the top and move the resistor here, and same here. So we are going to grab our ground wire, make sure it goes across all the way, and then from there I can take this wire, click on it, and then click the end dot, and I can just move it. Now it's only going to light up the red one. So I'm bypassing this positive rail down here and putting it directly into the column. So from there, I can click, let's say on D8, when I'm not simulating. Click on D8 and put that one there, and I'm going to leave this one actually a different color so I remember. So we're going to go back to the code editor, and we're going to copy this line here, paste it, delete this bracket. It's very important. Change LED built-in to 8. So now I have initialized both of those pins, because remember you have to do the setup for every pin that you want to use. And then I can copy this here and do the same thing. Paste it. Always get rid of your closing bracket if you're adding more. And I can put 8 here. And then just to make it fun, I'm going to put 8 up here as well. And now they should, oh, it didn't like it because I did not put the closed bracket back at the end. Now my red one turns on, then my green one turns on, then the green one goes off, and the red one goes back on. So I hope you enjoyed this little Blink project, and I hope to see you back in the library for our Arduino programs. Thanks for watching.